Now moving on to the part B of the problem, this is the figure given for the part B of the question. Once again, a circular path of the particle and the instant considered, the particle is at this position. It's moving counterclockwise in a circle of the same radius, 40 centimeters, and they have said in this case total acceleration vector is pointing radially inwards toward the center of this circle, and velocity vector of course is along the tangent drawn. This is the v vector, this is acceleration total, and they have further given the instantaneous speed at the given instant, that is 3.00 meter per second. So once you know the speed at the instant, you can once again find out the centripetal acceleration or radial acceleration by the formula AR is equal to V square by R. In this case, V is 3.00 meter per second, that is squared by radius remains at 0.400 meter, and this is coming out to be 22.5 meter per second square. You see, radial acceleration always points radii inwards towards center of the circle. So this is also the direction of the radial acceleration vector. But since the figure shows total acceleration also points radially inwards, it means this acceleration cannot have any tangential component. If you remember this parallelogram law of vector addition, only if the other component, that is tangential component, happens to be 0, only in that case radial acceleration and total acceleration will both be directed towards the center of the circle. So our conclusion is that in case B, radial acceleration or centripetal acceleration, whatever you call it, magnitude is this, direction radially inwards. Tangential acceleration is 0, which means the speed of the particle is not changing at this instant. Total acceleration vector, this one has magnitude same as AR, that is 22.5 meter per second square only, and direction of this acceleration A is also the same as AR, that is radially inwards. And here is the answers of the part B of this question. Let us see if we can accommodate the last and third part of the question on this page only. And in part C of the question, the figure given is this one. This is circular path followed by the particle as it moves counterclockwise. At a given instant, suppose the particle is at this position, velocity vector is along the tangent, and total acceleration vector of the particle is making angle of 30 degree with the radial direction as shown here. It is further given that the speed of the particle, this is v here, this is velocity vector, total acceleration vector, and v is given to be 4.00 meter per second at this instant. So as v is given, we can find out the centripetal or radial acceleration once again by the same formula v square by r. V is 4.00 meter per second, that is squared. Circle's radius remains the same, that is 0.400 meter as listed in the beginning, and calculation shows that this is coming out to be 40.0 meter per second square. So the first part of the answer, radial acceleration, magnitude 40 meter per second square, directed radially inwards from the particle's position towards circle's center. Well, let us refer to this figure now carefully, and I show it separately for clarity. The same figure, but a part of that only. This was the velocity vector along the tangent, and if I could take the two components of the total acceleration vector, So this is the vector A. This angle is given to be 30 degree. This is radial acceleration AR already found in magnitude. And suppose this is the tangential acceleration vector, which we call to be AT. You must have noted the direction of A is such that the tangential component of A is pointing in the opposite sense as the velocity vector, where both V and AT are along the tangent, but sense becomes opposite. So, referring to this right angle triangle, we could write down that since tan 30 degree is equal to perpendicular by base. Perpendicular is this much, that is the magnitude of AT. So tan 30 is equal to AT by magnitude of, well, this is the length of the base, and length of the base equal to magnitude of radial acceleration, that is AR. So it is following from here, tangential acceleration AT has got a magnitude of AR into tan 30 degree. The value of AR was just now found to be 40 meter per second square. And the tan 30 degree, as you know, is 1 upon root 3. Make the calculation and show that the value of AT in magnitude is coming out to be 23.1 meter per second square in 3 significant figures. So we conclude that, well, we must mention the directions also. The direction of AT vector is along the tangent drawn at the particle's position, but in the opposite sense as the velocity vector. Its magnitude is 23.1 meter per second square. And therefore, by parallelogram law, we could also find out total acceleration has a magnitude given by square root of AR square plus AT square. Putting the values, this is square root of 40.0 square plus 23.1 square, whole thing under square root, meter per second square, that is, I am getting to be 46.2 meter per second square. So that is the magnitude of total acceleration vector, and the direction is, if it's 30 degree, total acceleration vector is making an angle of 120 degree, isn't it? This is 90 degree, this is 120 degree with the direction of velocity vector. The obtuse angle signifies that the tangential component of the acceleration is pointing in the opposite sense as v, which means that at this instant the speed of the particle is decreasing. So let's collect the answers once again. For the part C of the question, centripetal acceleration, magnitude, direction, radially inwards. Tangential acceleration, magnitude, directed along the tangent, opposite to velocity vector. Total acceleration magnitude 46.2 meter per second square, directed at 120 degree to the velocity vector. And here are the answers of all the 3 parts of this rather simple question.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.